welcome back, and we are under the hood of a 6-wheel drive Land Rover Perentie Ambulance. This is one of two that I have. I have a 4-wheel drive job over there. This guy is an ex-ambulance, and we have a 24-volt alternator in addition to the 12-volt one. Lately this has been firing up and not charging properly. It'll charge for a little bit then kick out. Now, I'm midway through the diagnosis of this, so you're going to get that starting halfway through feeling. I got onto the Perentie Owners Australia Facebook group and had a chat to a bloke, and between us I think we've probably just found out that we're having some problems down here with this connection, and I think I might be having an arc over. We're not sure yet, but certainly that could be putting it into protection mode. And I don't like to see that kind of a connection to something that can provide up to 100 amps. So we definitely need to clean that connection up. This shroud here is connected to ground, and there's not much between that terminal and ground. So these do have a protection mode, and that would certainly be in keeping with its behavior. So I'm going to leave that unplugged for the moment. I'm going to do a bit of probing and testing, but I'm pretty sure that's going to be my issue. And whatever else is hidden under this factory installed insulation tape, or at least the previous owner. I do have a spare one of these plugs and a whole separate lead that I can go and swap out if I have to, but I'd like to try and sort the plug out at this end first. Anyway, let's move on and see what we can do. Okay, so I made a few advancements since the opening video here, and so let's discuss what I found. I stripped all the tape off this. We discovered some corrosion in here and some breaks in the cable. It's a pretty common thing because what it seems like in most of these is the strain relief that should have been installed in here has not been, for whatever reason, which has led to cracking and breaking the insulation near the plug. We looked at our spare loom, which is probably broken a little bit worse, but doesn't have the corrosion. We've dismantled the plug as far as we can practically go. So what we're actually going to do is do a chop and join with the other plug we've got, because the wiring is in slightly better condition, as is the plug body. So we're going to clean that up, put some glue fill heat shrink on, do as best we can to fit it. Then we're going to put a couple of giant crimp joiners on here and go from there. So hopefully that will do the job. So yeah, we're just going to get around at my my folks' place, so we're going to get that sorted out. Right, I'm going to do a bit of preparatory work here, or prep work, or preparatory, however you want to pronounce that. I hear things pronounced in weird ways on YouTube all the time. Anyway, I've got some electrical cleaning lube here. This is designed for cleaning electrical contact and mechanical surfaces. So it has leaves a layer that reduces wear and oxidization, but it's also a good solvent as well. So we are going to get good and proper in that connector and around the screw as well, because it has a bit of lubricating properties. That should help decrease the contact resistance when we connect there, which will help probably get a bit more current into the batteries, but as well as that, it reduces the chance for arc overs and stupidity like that. We're going to chop this guy off, so we're not going to worry too much about that, but I might use this as a bit of a test run to see how this stuff works in there. It looks like it's going to clear the contacts nicely, and it looks like our A contact, which is our positive wire, has been a little bit hot. So my father's suggestion that, or my senior technician's suggestion that the arc over has probably overheated the plug is probably not too far from the truth. I can get into here a little bit just as a matter of interest. That has cleaned up some of it, but yeah, that wire has been hot, and which means it's probably a little bit brittle now. So I'm not too unhappy about cutting that off. I've also got a piece of heat shrink, glue-filled heat shrink that I just put down and lost. This is what we're going to use. It's dual wall heat shrink tube. When we do the new plug, we're going to put some heat shrink over all of this stuff as well. Oh, a bit of steam come off that. That's on the top of the exhaust manifold and the turbo there that's hot. Right, anyway, that's 12mm stuff. So we're going to borrow my old man's big gigantic crimpers, and because we use some 8-ton hydraulic crimpers to put the terminals on the plug at the electronics shop. Yeah, I'll chuck a link to them below. It's a very good shop to go to, and so hopefully this should work once we're in there. I'm not sure we're going to go as far as wicking any solder into those crimp terminals, but see how we go. I'll find myself a little gas torch too. I think I've got one in the side. So we're going to want, how much for this one? I want that much there. Alright, that should help a little bit with the containment, 24 volts. A little bit more in there, should be pretty good. Now I've got to put a couple of bits on for when we do the crimp joins to cover them as well, because we don't want them slapping together under the bonnet. So I might thread these down the other end and get them all out of the way. Just because I've got all this nicely trained, so I can push the heat shrink over this glue filled stuff's really grippy. Shove that right there. Alright. Now that should be isolated, but I can put a meter on it if you want to be sure. Yep.
Points.
On those, well then.
They're rubbing off.
Probably try sort of file in this kit. That will probably be sufficient to do the job, I would guess. Got this guy. It's 7 volts. I'm very glad I checked that. That would have been a bit of a surprise. Unless we cut one at a time. Should be alright. I may have to disconnect right at the batteries directly. So let's go see if there's a way to isolate. To be sure. Have a little bit of feedback from capacitance. About 2 volts we're dropping. You're good. I can put one set of ratchet crimpers like that. Not so fun when you crimp them onto your shirt. It's by accident.
You want to do the join here, do you?
Wherever it's convenient, because we've got a bit of length, so
Yeah.
wherever you think is best. I reckon probably some point above that, probably.
Yeah, so there.
Because I think looking at these little, this is where they've had all the tape and stuff on, and
Yeah.
so I think probably they've had problems with it before, because when I peeled the tape off, there was a piece of hose pipe wedged in between them and taped on.
Yeah, so it's placed over once before.
Yeah. And that would explain why I'm having belt slip, even though the belts are reasonably tensioned on here. Probably get better fuel economy now too. I'm going to get asked questions about how I solved this, so I'm going to film it and take photos. I got some grit soap in the back. That'll, there's a cold drink in the fridge. Yep. Yeah, now there's the log there. So it's actually facing the front. It's always the time for the phone to ring. I was just going to let it go message me. I can probably finish up the rest of it anyway. And you need to adjust your jaws open a bit.
Moving in.
Yep. Clearly we can, so let's fire us up. We're in full sun, so we won't see much. Let me go put the 15 amp load on. We should see when we start driving when the alternator kicks in. Okay, so it's the next morning and we've left the solar panels disconnected, so they haven't charged in the morning, and we've left the fridge running all night, so we're at 24.1 this morning. We had some unpredictable results with the charging, and we think maybe it was because I'd already charged the batteries up, but we're going to get in, start her up today and see what happens. Alright, we have no other source of charging, so let's see what happens today when we start the engine. So no change so far, and the current analyzer says 300 milliamps. Give it a few seconds for oil to get through the turbo, and then let's pull it up to a higher revs. Expect there to be some sort of increase in voltage at this point. Current analyzer says 300 milliamps going in, or maybe going out. It's not definitive on that. I don't think the alternator's working. Alright, So unfortunately, we don't seem to have solved the alternator issue. So I think we're going to need a solar backup here. Plug you guys back in and we'll see what goes in. It's 24.4 volts. We're putting about 3 amps in for now. As the sun comes out, we'll probably get some better charge. And yes, now we're seeing an increase in voltage on there, even with just that 3 amps in there. So definitely alternator's not charging. There is some suggestion that it's possibly a relay inside this box that's got something to do with it. Fortunately, this box is easy to open, so it could be just the sense wire, the excitation wire, because alternators require a little bit of current in the primary field or primary coil to generate a magnetic field for the alternator to do its thing. Now this doesn't have any moving brushes. This is a laminated steel core with a fixed stator, so even then it still requires a bit of current. So I could stick my clamp meter over the wires and see if it's generating any current. I was generating 3 amps yesterday, or maybe using 3 amps, I don't know. So I'm going to investigate this further. But anyway, this is one thing certainly to check with these, is that connector. So I think at this point we're going to cut this video here and call it a failure, and we'll find the problem in another video. So I hope you had fun, and we'll come back to another one in the near future.